Today we have learned about common emitter, common base, and some of the other memory devices. First, I'm gonna review about common emitter and common base. For last, I'm gonna introduce about memory devices. First, common emitter is a device which emitter is grounded, and by the Miller effect, as the current gain increased, capacitance that are inside of the device seems to be getting bigger, and by the result of this, bandwidth of filter would be decreased. Common emitter usually used to amplify the signal, and usually its current gain is nearly 100. For common base is grounded. Almost all current from the emitter goes through the collector. And for common base, only voltage is amplified. Current amplification is less than 1. Input impedance is low and output impedance is high. By these characteristics, it is not used widely nowadays. And this is how equations about how we get each gain by using alpha and beta and emitter current and collector current and base current. And for next chapter, we had learned about memory. There are two types of semiconductor memories, as you can see this page, which is divided into RAM and ROM. In this chapter, we will focus on the SRAM, DRAM, and flash memory. First, I would like to introduce about memory architecture. As you can see in this circuit scheme, we call this structure as peripheral circuit, and we call peri for convenience. For RAM, it is an abbreviation of random access memory. A random access memory device allows data items to be read in and written in approximately the same amount of time, regardless of the order in which data items are accessed. For SRAM, it is an abbreviation of static random access memory. It is type of semiconductor memory that uses bistable latching circuitry to store each bit. This page, I'm going to introduce about SRAM's operation. If the Q point is charged with high, the M1 transistor will be on and M2 will be off, because M2 is PMOS and M1 is NMOS transistor. Since M1 transistor is turned on, Q bar point will be 0 because it is directly connected to ground. Since Q bar point is low, the PMOS transistor M4 would be turned on and Q point will be high. State is same mechanism compared to previous. For DRAM, it consists of one transistor and one capacitor. For this aspect, DRAM is very economical. But it also has the effect which is data loss as time goes on. To solve this problem, we have to refresh the device by using peri circuit to compensate the defect. To summarize, SRAM is 61 cell and has high speed, static when power is applied, and has lower power dissipation. For DRAM, its structure is 1T, 1C with 1 cell. Each operation is very slow and we have to refresh frequently, also it has higher power dissipation. Thank you.